What is a limit? In simple terms, a limit tells us what a function is approaching as we get closer and closer to a certain value. For example, if I have the function f of x is equal to x plus 2, and I want to find the limit as x approaches 3, then I ask, what value does f of x gets close to as x gets closer and closer to 3? In this case, it's pretty simple, because we are just inserting 3 into as the input of this function, and we get 3 plus 2, which is 5. But the mathematical way of writing this, the mathematical notation, is like that. Limit x approaches to 3 at this function is equal to what? In this case, we can use direct substitution, and we can directly substitute 3 into this equation, and we get 3 plus 2, and this is 5. So the answer to this problem is 5. It's pretty simple, right? But unfortunately, limits aren't always straightforward. Now let's say we have such kind of problem. Limit x approaches to 1 of x squared x power 2 minus 1 over x minus 1. What should we do? We can't directly substitute 1 into this equation, because if we do so, then we get 1 minus 1 over 1 minus 1, which is 0 over 0, and this is undefined because we cannot divide any number to a 0. So what should we do here? We know that we are interested in the value that this function gets as x gets closer and closer to 1. So let's substitute any number into this function which is very close to 1. So let's do 1.1 for example. So if we substitute 1.1 into this function, we get that it is equal to 1.1 squared minus 1 over 1.1 minus 1. So this is 0.21 over 0.1. And this is 2.1. So this value is pretty close to 2, right? Now let's say another number, for example 0.9, and in this case we get that it is equal to 0.9 squared minus 1 over 0.9 minus 1, and this is equal to minus 0.90 over minus 0.1, which is 1.9. So this value is also very close to 2. So from that only we can assume that the answer to this problem, the solution, is 2. But of course this is not the optimal way of doing it, and also we are just assuming we do not know if our answer is correct or not. So how do we check it? The correct way of doing this is as follows. So limit, let me rewrite this because it is important, as x approaches to 1, and here x squared minus 1 we can write in different way, which is x minus 1 times x plus 1, and down in the denominator we do not touch anything because we have x minus 1, and now we can clearly see that x minus 1 and x minus 1 cancel out each other, and we are only left with x plus 1. So let me rewrite this limit notation again as x approaches to 1, and I have only left here x plus 1. Now it's time to use direct substitution, and we can substitute x with 1, and what we get is 1 plus 1, which is equal to 2. So this is the solution of our problem. Another interesting case is when x approaches infinity. So let's consider this problem. Limit x approaches to infinity of 1 over x. As here we can try and substitute some numbers into that function. So let's substitute 10. F of 10 is equal to 1 over 10, which is 0.1. Let's substitute higher value of x, so let's say 100. F of 100 equal to 1 over 100, which is 0.01. And we know that 0.1 is more than 0.01, and also know that 100 is more than 10. So here we can say that as x gets larger and larger, the value of this function gets closer to 0. So we can say that as x goes to infinity, the value of this function goes to 0. So the answer to this question, to this equation, is 0. Now take a look at some polynomial functions. Let's say the slight x approaches to infinity of x squared plus 3x plus 5. When we are dealing with limits and x is approaching to infinity and we have polynomial functions, we must remember that the highest power of x dominates, meaning that fx behaves like x squared in this case. Thus we say that this is equal to limit when x is approaching infinity of x squared. And now here we can simply see that the limit of x squared when x is approaching infinity is also infinity. Now let's look at another example. Limit x approaches to infinity, and let's say we have x cubed plus x squared plus 5 over x over 2 x cubed, this is cube, plus 1. What do we do in this case? So as I said, the highest power of x dominates. So we take only highest power of x from the numerator, and we do same for denominator, and then divide them on each other. So let's rewrite this limit x equals approaches to infinity of here only x squared, x power 3 is what we are interested, and here only 2 times x power 3. Here we can see that x power 3 and x power 3 cancels out each other, and what we are left with is 1 over 2. So the answer to this problem is 1 over 2. Now write the example where the power of x in the numerator is larger than denominator. So for example, we have this function x power 4 plus 3 over x power 3. As I said, highest power of x dominates, so we are only left with x power 4 in the numerator and x power 3 in the denominator. So here we can cancel x power 3 and we are left with only x, so we get limit x approaches to infinity and only x here, and this is infinity itself. Now one more example. x approaches to infinity. Here, let's say x cubed plus x squared over x power 5, and the highest power of x in the numerator x power 3, so we are only left with x power 3. We are only interested in x power 3 in the numerator because it's highest, and x power 5 in the denominator. Now let me rewrite limit x approaches to infinity again, and here we can cancel x power 3, and it is 1, and when we cancel x power 3 from x power 5, we are left with x squared, and answer to this problem is, as in this example, also 0. Now notice that here in the last example we have function where the power of x in the denominator is more than power of x in the numerator, so we call such functions bottom heavy, and when the function is bottom heavy, the limit of this function when x is approaching to infinity is 0. On the contrary, when the function is top heavy, so when the power of x in the numerator is more than power of x in the denominator, we call this top heavy, and the limit of this function when the x approaches to infinity is infinity. And when the function is balanced, so the highest power of x in the numerator is equal to highest power of x in the denominator, we just divide them to each other, and that's our answer.